Hello students, let us practice few more questions on numericals from the topic reflection. Okay, let us start. 10 questions already you have done. Now this is question number 11. An object 4 cm tall is placed on the principal axis of a concave mirror of focal length 20 cm at a distance of 30 cm from it. Find the position, nature and size of the image. First of all, you see it is the what? Concave mirror, right? It is the concave mirror. So the image could be either what? Image could be either virtual or it can be real. So let us find it out. What the data given. First of all, the object size it has been given, that is 4 centimeter. This is HO, so we have to write HO equal to 4 centimeter. Now it is saying that focal length for the concave is always negative, so we have to write this minus 20 centimeter. Object distance will also be always, because the object need to be in front of the mirror, so it will also be negative. As per the sign convention, you already learn about it. So just if at all you are not remembering that, just go through it first, so easily you can understand why this negative sign we are taking, right? So u equals to minus 30 centimeter. Now use this mirror formula and put the values, and you will get v equal to minus 60 centimeter. This minus sign of v is indicating the nature here. Okay, and also the position and nature we got for the image. Now the next part is, that is the size of the image. Now we have only HO value. We do not have M value, or we do not have HI value. So the other formula we have to use, that is M equal to minus B by U. Now V's value is what? You have to see that here minus and then again minus 60. Okay. Once more I am writing here. You must be knowing this. This is minus, then minus 60. So this becomes what? Minus minus plus. So here, that is the reason at this point we have not noted any sign. That means it is a positive one. Now U value is minus 30. So you just substitute that values and you will get M equal to minus 2. Now HI by HO, the other formula, because we have to find out this one HI. So just substitute the values of M here, minus 2, and HO value also you have to put, and you will get minus 8 centimeter. This is the size of the image we got. Now ultimately this position, nature and size we have to write. See the green boxes at the end, you have to write the position of the image is beyond the center of curvature at a distance of 60 centimeter from the pole. Okay, here from the pole, in front of the mirror also you mention, in front of the mirror. Okay, 60 centimeter in front of the mirror, it will be more clear. So now the second part is your nature. The nature of the image is real and inverted. You already we have discussed for here. The minus value of the v is indicating that. And now the size of the image is 8 centimeter. 8 centimeter we got it here. So the size is 8 centimeter. Okay. Now the next one. Question number 12. Question number 12 is quite easy. You can just think about it. You can do it quite easily. A concave mirror produces a real image of size 3 times that of the object at a distance of 30 centimeter from the pole of the mirror. Find the position of the object. Now it is 3 times if it is comparing the size of the object and the image. That means that is the magnification value. Whatever is the, if it is comparing the real image and the object, it's sometimes it has been saying, so that means it is the magnification value. Okay, so because it is a concave mirror, so you come to know that it is a minus sign we have to put in for the magnification. Okay, if it is a magnification becomes minus, then what type of image it will be? It must be real. So now here the question is not asking about the nature, only the position of the object you have to find it out. So the only important part is to find this magnification value. Now it is after this it is also asking, it is also given that the object at a distance of 30 centimeter. Okay, it is asking for a concave mirror produces a real image of size 3 times that of the object at a distance of 30 centimeter. Children, try to read this again and again. You will understand that it is asking, it is saying about the image distance. Okay, image is 30 centimeter from the pole of the mirror. Okay, so now v equal to minus 30 centimeter. We have already discussed about it, why this is minus. Now magnification we have to find it out, because we have to find out the position as well. So it will be easiest formula to put it, because we don't have the focal length in this question. So you need to use this magnification formula here to get the position of the object, that is u. Okay, u equal to minus b by m. After from this magnification formula we got this formula, and then just substitute the values whatever we had written, these two, and then you will get minus 10 centimeter. Okay, object has to be my object position has to be minus always, that is clear. Now the distance is what, 10 centimeter. So what to write? The position of the object is 10 centimeter away from the pole in front of the mirror. Here this in front of the mirror, that part you have to write, that is quite important. 10 centimeter away in front of the mirror. This is the main answer that you need to write. Or if you confirm, I mean you are quite sure about the answer, then you can write the way I have written this one. Okay, I hope this one is also clear. Children, let us move to the next question, that is question number 13. How far should an object be placed from the pole of a concave mirror of focal length 20 centimeter to form a real image whose size is 1/5 of the size of the object? Now here again it has been compared. Okay, the image, real image and the object size, real image size and object size is been compared, that is 1/5. So that means what, as just now in the previous question I told you, if any comparison is been given between the image size and the object size, that value whatever is been given, that is your magnification. Okay, so just write it down. The m values, that is 1/5. Why again it is minus? Minus because of concave mirror. Okay, focal length is also 20 given, so it will be minus 20. Now what we have to find out, how far should the object be placed? How far should the object be placed? Means object distance we have to find out. Let us take u equal to minus x. Minus x, why? It has been x, but u value is always negative, so we just put minus x over here. Now put the magnification formula here. This one, the magnification formula, m value we already know, that is minus 1/5. By substituting everything, you will just find out v equal to minus x by 5. Now we got it, because we have to find out the object distance. So u we need to find out, which is we had taken as x. Now just substitute the value that we got it in the mirror formula. Here in this formula you have to substitute it. V equal to, here the v value is what, x by 5. If we will write at the bottom here x by 5, what we will get, just because it is 1 by x by 5, so it will become 5 by x. I hope it is clear to you all. Now it is this one is clear. Now u is x we had taken, now again it will be minus. So this is what we had written, and the focal length is minus 20. So here it has been just substituted. Now x you have to find it out, and just you will get this particular equation. It will be minus 120. Now minus x is what? It is just u, isn't it? So it is just u value you will get minus 120 centimeter. I hope it is clear. Now it is a very simple question. You just need to write the object should be this answer. I'm talking about the object should be placed 120 centimeter away from the pole in front of the mirror. I hope this one is clear. It is quite easy, but still you have to concentrate what is been given and accordingly you proceed further. Now the next question, question number 14. Here the question is saying a 3 centimeter tall object is placed 18 centimeter in front of a concave mirror of focal length 12 centimeter. At what distance from the mirror should a screen be placed to see a sharp image of the object on the screen? Also calculate the height of the image formed. Again, this type of questions already you have done, but a little bit extra points it has been asked, so you can easily do it. So just let us see that what is been given. 3 centimeter tall object. So this is HO. Okay, this is HO. HO is 3 centimeter. Now this object is been placed 18 centimeter in front of the concave mirror. It is a concave mirror. First of all, just check out what type of mirror it is been saying. So U equal to minus 18 centimeter. Right? We had written minus again because it is an object distance. Now the focal length is 12 centimeter in the question it has been given. So because it is a concave mirror, again minus 12 centimeter. Now substitute these two values in a mirror formula to get the value of B. Why we are calculating V? Because we have to find out the magnification. From that we can find the height of the image. Okay, the question is asking for the height of the image. Height of the image directly we cannot calculate because we know that the formula M equal to HI by HO. This formula we even if we have, but the values, the data are not sufficient. So we have to calculate the magnification value. Then we can use this HO value as well to get the size of the height of size of the image. So for that we need another formula of magnification, and because of that we are calculating V as well. I hope it is quite clear how you are proceeding. So V value we got after substituting all the value, V value we got minus 36 centimeter. So because we got the value in negative, I mean this is minus 36. So here we got the nature, if at all, if in the question it will be asked. So you have to just remember what is asking in the question and accordingly you have to answer at the end, like the way I had shown in the green boxes. Now M equal to minus V by U, substitute the value, you got the magnification value as minus 2. Now substitute in another formula, that is HI by HO equal to M. In place of M it is directly been written minus 2, and HO value is how much? HO value is 3 centimeter here. Okay, 3 centimeter. So it will be HI becomes how much? It is minus 6 centimeter. Now let us see how to answer it in the green boxes. At what distance it is asking from the mirror should a screen be placed? Screen be placed, screen distance is equal, I mean it is same as the image distance. Got it? So whatever image distance in V you have got, that is the position, that should be the position to get a sharp image, position of the screen I mean to say, right? So the screen should be placed at a distance of 36 centimeter from the pole in front of the mirror to obtain a sharp image. You have to write that way. So again I am reading this particular part. The screen should be placed because it is asking for the distance of the screen, but you should understand the screen should be placed at that position where the image is forming, isn't it? So only because only at that point only you can get the image. So for the sharp image, that distance is important. So V is our answer actually for the first part of the question it has been asked. So children, you have to write the screen should be placed at a distance of 36 centimeter from the pole in front of the mirror to obtain a sharp image. Now the second question, it is the height of the image it is asked. So height of the image we had calculated over here, So the height of the image formed is 6 centimeter. I hope it is quite clear to all of you. Let us see the next question. This is also quite easy one. You have done this type of question, but here it is the question asked is a little different. Okay. Just see, a concave mirror produces 3 times magnified image on a screen. If the object is placed 20 centimeter in front of the mirror, how far is the screen from the object? Isn't it quite easy? Because already I told you, if a concave mirror produces 3 times magnified image, that means 3 times magnified image from whom? It is from the object. So again a comparison, 3 times means it is the magnification value. Okay, again it is a concave mirror, so the value will be what? It is -3. Now if the object is placed 20 centimeter in front of the mirror, object is what? U, and U is how much? It is -20 centimeter. Now M equal to minus B by U, this formula, and now just put all the value that you know, these two, and you will get easily the value of B. So it becomes -60 centimeter. How far is the screen from the object? The screen is at a distance of 60 centimeter from the pole in front of the mirror. This should be your answer. I hope it is quite easy. Now you got it how to proceed. So now question number 16. Question number 16 says what? Where should an object be placed in front of a concave mirror of focal length 20 cm so as to obtain 2 times magnified virtual image of the object? Okay, so here just little bit twisted question, but you can easily answer it. It is not a difficult one at all. Just think about it. So here now magnification is 2 times. Okay, but it is a virtual image, right? It is a concave mirror, but it is a virtual image. In case of concave mirror, we took minus for the real image. Okay, if it is a virtual image, then we have to take it as positive. M equal to only 2 we have to write. Okay, now the focal length is 20 centimeter. Focal length is 20 centimeter means F equal to minus 20 we have to write. Now we have to calculate, we have to find out the object distance from the mirror. Object distance means U is minus x. Okay, U will be always minus, so we had taken minus x centimeter. Now put this value to get V, so V will become 2x centimeter. Right, now you got in the x form, you got the value of U, you got the value of B. Right, put substitute in the mirror formula, you will get the answer as U equal to minus 10 centimeter. So just simply in the green boxes, the way it has been written at the end, at the bottom of your answer, you can just write the object should be placed 10 centimeter away from the pole in front of the mirror. I hope this is also a quite easy one. You got it. Now the next one, question number 17. Okay, let us read the question. A 5 centimeter tall object is placed at a distance of 20 centimeter from a concave mirror of focal length 30 centimeter. Use the mirror formula to determine the position and size of the image formed. Okay, now again it is the object size, it has been given, so HO equal to 5 centimeter we had written. Now the object is been placed at a distance of 20 centimeter, so U equal to minus 20 centimeter. Okay, the focal length has been given 30 centimeter, so F equal to minus 30 because it is a concave mirror. Right, now substitute in the mirror formula. First you have to write the mirror formula over here and then substitute all the value. You will get V equal to 60 centimeter. Here you can see that V is positive, and as it is in the question we have already seen that you have to find the position and size only. We don't need the nature. Now for finding the position and size, we have to use the magnification formula. Position already we got, V equal to 60 centimeter. Now we have to go for the size of the image. Just this process we have done so many times, so just you can do it. M equal to minus B by U here, then substitute the value, you will get M equal to 3, and HI by HO equals to M, so just M value you have to put, and HO value is 5 centimeter over here. Just it will be crisscrossed and then multiply, that answer will be 15 centimeter. Here the ultimately we have to write the position and size. The position of the image is 60 centimeter behind the mirror. Here it will be behind the mirror. Okay, so that is the reason V becomes what? It is positive, because behind the mirror we are getting it, and it is a virtual image, isn't it? Though it is a concave mirror, you know there is a case where it is virtual. So it is that case only. The size of the image is what? 15 centimeter. I hope all of you clear in this question. Let us move on to the next question, that is question number 18. An object 3 centimeter high is placed at a distance of 10 centimeter in front of a concave mirror of focal length 20 centimeter. Find the position, nature and size of the image formed. Okay. This is also quite easy. You have done so many questions based on this, but just for practice I had given again and again with different value. So do it by your own, children. You can just do it by without seeing the solution as well, I'm sure. So the object is 3 centimeter high. So HO is how much? It is 3 centimeter. Now this object is placed at a distance of 10 centimeter in front of a concave mirror of focal length 20 centimeter. Okay, it is again a concave mirror case. So just remember that what should be the nature, what could be the nature, whether it is a real one, whether it is a virtual one, that keep in mind, and then you have to proceed further. Now U is always minus, so it is minus 10. Focal length, because it is a concave, so focal length is minus 20. Now we have to wait for the value of V. Now here again you have to write the mirror formula, then substitute it. Due to the space, because of the space, lack of space, I have to skip that particular mirror formula again, writing that part again and again. So just substitute the value. 1 by V equals to 1 by 20. Now V becomes how much? It is 20 centimeter. Again we have to find out the size of the image, and we don't have the sufficient data, like a magnification value we don't have. We have to calculate it, and we have another formula luckily. So that formula we have to use, and then we will get the value as 2 here. Substitute that particular value in HI by HO, that is 2. HI becomes 6 centimeter. Okay, now we have to find the position, nature and size of the image. Position is how much? Position is here we have calculated, that is 20 centimeter behind the mirror. Okay, it will be behind the mirror because it is positive. V value is positive. So that will become, so what we will have to write? Behind the mirror. Now if it is a behind the mirror and is a concave mirror case, then there is only one case where the nature is what? It is the virtual erect, and the positive sign of B also saying that it is virtual and erect one. And the size of the image is how much? It is 6 centimeter. We have just calculated. Okay, I hope this one is also clear. Children, let us proceed for the question number 19. The concave mirror produces 2 times magnified real image of an object. Again, it is a concave mirror, but here just remember whether it is saying the real image, because it is a concave mirror. If it is real image, then it will be negative. If it is a what? If it is a virtual image, it will be what? It will, the magnification value will be for virtual, it will be positive. Right, again it has been compared 2 times. It is saying for with the real object and the object. Object is placed at 10 centimeter in front of it. Find the position of the image. Quite easy. So m equal to minus 2. Here, as I have explained why it will be minus. It is a real image of a concave mirror, so it will be minus. Right, if at all it was given as a virtual image, then it will be positive. U is always minus, so it is minus 10 centimeter. And let us substitute. It is a very simple question. It is just asking for the position of the image, not the size. So for the position, we have to just calculate the V. So V will be calculated by this formula only. Substitute all the data given, these two, and then you will get minus 20 centimeter. So ultimately, we will write the answer, which is I have written in the green box. The position of the image is 20 centimeter away from the pole in front of the mirror. I hope again, children, you are quite clear let us move on to the last question of this video, that is question number 20. Okay, the image of a candle flame placed at a distance of 30 centimeter from a mirror is formed on a screen placed in front of the mirror at a distance of 60 centimeter from its pole. Okay, now just you have to understand this candle flame, the image of a candle flame. So candle flame is the object, the image of the candle flame is placed at a distance of 30 centimeter. Okay, so the object distance is here minus 30 centimeter. Okay, now it has been saying that the image of the candle flame placed at a distance of 30 centimeter from a mirror is formed on a screen placed in front of the mirror at a distance of 60 centimeter from its pole. Right, so the image will be at 60 centimeter away. Okay, so this V is minus 60 because it is all in front of it, it is saying, so we have to take minus for all this. Now HO equal to, it is 2.4 centimeter, it is already given. Use the mirror formula. These are the given, whatever is given we have to write first for the solution. Then you have to use the mirror formula to get the focal length. Focal length, why we need that? Because it has been asked, find its focal length here. Okay, then the nature of the mirror means what type of mirror it is asking. So all this we have to keep in mind. Let us see. 1 by f equal to minus 3 by 60. After substituting the value and you will calculate, you will get f equal to minus 20 centimeter. Now the second part, we have to find out the height of the image. For that we have to again use this formula. If at all we had the value of magnification or HO or HI out of these three, any two value we would have, then we can go for that particular formula directly. But we don't have that one. We have only HO value. We don't have magnification because we have to calculate this height of the image. Okay, so we have to go for the another formula, that is V minus V by U. Just substitute the value, magnification you will get minus 2. Here it is already minus 2, means it is a concave mirror. But what is the nature, that we will see of the image, right? Because here it is at last again it is asking, state whether the image formed is erect or inverted. Okay, so now HI by HO equal to minus 2. Now HI you will get how much? It will be minus 4.8 centimeter. This one is the answer. Now let us answer one by one. What is the nature of the mirror? That means what type of mirror it is. The nature of, if it is asking nature of the mirror, means first you have to write whether what type of mirror. If it will be asked in the question, then directly you can write concave mirror. But it is asking about the nature of the mirror, that you have to write whether it is a converging one or a diverging one. So we know that concave mirror means it is converging. So you need to write the nature of the mirror is converging, as it is a concave mirror. Okay, so you have to write like that. Now again you have to write find its focal length. Here I have missed some of the answers. You have to write the focal length will be minus 20 centimeter. If the height, it is asking for the height of the image. The height of the image is 4.8 centimeter, and it is again asking the fourth part of the question, state whether the image formed is erect or inverted. If it is a real one, that means what? It will be a inverted, because we already know that V is minus, so it is a inverted one in front of it. And for inverted, you know that it is a concave mirror, and all this knowledge will help you out to find out the image nature, right? So just include in the answer or the focal length. Here focal length part is missed, so you just write it down in your answer. I hope you all are clear with all these 10 more questions we discussed. In another video I will give you 10 to 12 questions. Till then, bye bye, and thank you children.